Hey, welcome to The Explainer. Today, we're going to pull back the curtain on the technology you use every single day. We're breaking down the secret recipes and visual blueprints, the algorithms and flowcharts that make it all possible.
So let me start by asking you a question. Have you ever tried to explain a simple task to someone, like how to make a sandwich, only for them to get it completely, totally wrong, right? It happens because our instructions can be a little fuzzy. But what if you could create instructions that were literally foolproof?
Well, in the world of computers, the solution to that problem is something we call an algorithm. And honestly, the best way to think about an algorithm is just as a recipe. It's a set of steps so precise, so crystal clear that there's simply no room for error. You give it the ingredients, that's the input, and it absolutely guarantees you get the right dish, the output, every single time.
Okay, here's a perfect example. A super simple algorithm or recipe for finding the largest of three numbers. Now, notice how it's just a list of steps, but it's incredibly precise. It doesn't just say, find the biggest one. It spells out every single action, from the moment you start to the moment you stop. Nothing at all is left to chance.
You know, for any recipe to really be considered a proper algorithm, it has to follow three basic rules. First, it has to be unambiguous, no vague instructions allowed. Second, it has to be finite. It must have an end. It can't just go on forever. And third, it needs to be general, which means our recipe for finding the largest of three numbers has to work for any three numbers you decide to give it.
But let's be real. Just reading a list of text instructions can be kind of dry, and sometimes it's hard to see the big picture. And that's exactly why we have a visual equivalent, the flowchart. So, if the algorithm is the written recipe, think of the flowchart as the architect's blueprint. It shows you exactly how everything connects.
And this blueprint, well, it uses its own kind of universal language, made of symbols. We use a rounded rectangle for the start and stop points. A parallelogram is for getting data in or pushing data out. A plain old rectangle is where the work gets done, the calculations. And the most important one for us today is the diamond. That's where a decision has to be made. All right, let's actually build the blueprint for our number-finding recipe step by step. Every good plan needs a clear beginning, so we're going to start with that terminal symbol that just says start. Simple enough.
Okay, next up, we need our ingredients, so we'll add the parallelogram, which is our input symbol. This shape tells the process to read in our three numbers. We'll call them A, B, and C.
And here's where things get interesting. We've hit our first fork in the road. This is where that decision diamond comes into play. It asks a simple question that can only have a yes or no answer, and that forces the logic to split down one of two paths. Our first big question is A bigger than both B and C?
So if the answer to that question is yes, then the logic is super simple. The flow follows the yes path straight to an output symbol, which just displays our result. A is big. And just like that, that branch of the problem is solved. Done.
But what if the answer is no? Well, if A isn't the biggest, our journey isn't over. The logic has to continue down the no path to a second decision diamond. Here, we ask a new question to figure out the winner between the remaining two. Is B greater than C?
You can see what's happening here, right? This structure creates a clear, visual path for every single possibility. If B is bigger, we say it's the winner. If not, then C has to be the biggest. And this is crucial. All of these paths eventually come back together and lead to our final terminal symbol, stop. This makes sure our process always finishes and never hits a dead end.
Okay, so we've got our text recipe and we have our visual blueprint. They're awesome for planning. But how in the world does a drawing on a page actually become a working app on your phone?
Let's see how this blueprint becomes real code. Let's zoom in on that diamond symbol one more time. Remember, it represents a choice, a fork in the road based on a simple yes or no question.
In pretty much any programming language out there, that visual diamond translates directly into a command. It's usually called an if-else statement. You're literally telling the computer, if this condition is true, do this one thing. Else, do this other thing. The blueprint literally dictates the structure of the code.
And here's the really cool part. This one-to-one connection applies to the entire flowchart. Every symbol has a direct partner in the code. Those input-output parallelograms, they become read and print commands. That processing rectangle, it becomes a line of code that does a calculation. Even an arrow that loops back on itself becomes a loop in the code, telling the computer to repeat an action over and over.
You know what? Let's tie all of this together with one final analogy that's going to make it all click. Let's think about building a house. First, you have the algorithm.
Think of this as the super detailed, step-by-step instruction manual for the construction crew. Step 1, lay the foundation. Step 2, assemble the wall frames. It's incredibly precise, and it has to be done in order.
Then you have the flowchart. Now this is the architect's blueprint. It might not list every single nail and screw, but it shows the overall layout, the flow of the rooms, and how all the major systems connect visually. It's the master plan.
And finally, you have the program itself. Well, what's that? It's the finished house. It's the real, tangible, functional structure that you can actually use. And it was built precisely according to that detailed manual and that visual blueprint. You simply can't have the house without the plan.
So here's the main takeaway. From the most complex video game to the simplest calculator app on your phone, every piece of software starts out exactly the same way, as a simple recipe and a visual plan. Which kind of leaves us with one final thought. What recipe will you write?